Okay. Looks like we're good to go.
Cool. Did you do? Those are the cutest sneezes I have ever heard. Oh my goodness. Mine are like obnoxious.
That's nice. I was trying to be a little more quiet.
Ugh.
We're not usually like that. Okay, I'm finishing up pulling up the quiz. Sorry.
No worries. I did the first question, number 3. It was really easy.
Oh, good.
From my understanding, maybe it's not that easy, and maybe I was just read it wrong, but it was really easy from my understanding. So hopefully that was right.
Well, what'd you get?
0.175 rounded.
0.175?
Yes.
Let's see. Use a normal probability. Oh, just a normal probability applet, yeah.
Yeah, and then I just highlighted the one to the right and the one to the left, and I got 0.1745, and then it said to round to the third decimal.
That is correct.
But I was like, that was really easy, so.
Yeah, the applet thing is really nice.
Oh my goodness, yes. So nice.
Mm. Okay. Holy cow. Sorry, I feel like I'm shaking my laptop, so I don't know if you guys are watching.
It's okay.
Okay, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
Okay. Wait.
Any guesses or thoughts?
I'm sorry, I'm like going back through the chapter to see.
Yeah, same. Sorry. Everyone was just like dead silent for a second.
Yeah. Like trying to make sure.
I'm not sure I like understand what's asking for me.
Me neither. But my guess would be individual observations. Because how would it have a standard deviation if it's only one observation? Because then that would be the mean, and there's no deviation from the mean. Then
that's
my thoughts on it, but I don't know if that's right.
I was thinking the same thing. I just like wanted to make sure before I said anything because I didn't want to be wrong. But when you explain it, it makes sense. So
I mean, it doesn't mean it's right, but that's my thought process with it.
I'm good with it. I trust you.
Which of the following? Or sorry, are we ready? Is that what we want to try? I was about to just move on.
Yeah.
Okay, I'll read the next question, number 5. Which of the following results implies that the spread in X decreases as the sample size increases? X decreases as the sample size increases.
X decreases as sample size increases.
No, this is like all review.
Is this like a prepared for our test?
Right. My notes. I wrote this down.
For me or for both of us?
Okay.
Probably no cheddar.
The law of large numbers is as the sample mean gets larger, then sample mean get closer to the population mean. That's not really the same. And then central limit theory and is one of their, like, how to say if the sample means are normal. But what's the normal distribution? Or maybe it's a law of large numbers.
This in the review of our chapter says the central limit theorem guarantees the distribution of like the x is normal if the sample size n is large enough.
That's what I was thinking. I was thinking central limit theorem, but I don't know.
I mean, it's not like word for word, so I'm not sure, but I mean, maybe.
I'm gonna try it. That's what I was thinking as well.
Which is
okay. Oh.
okay.
Well, we can try. I was thinking. Okay. I can read number 6. So scores on the quantitative portion of the GRE are approximately normal, distributed with mean equals 150.8 and standard deviation equals 8.8. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
I have it if you guys want. It's just the score 160 minus the 150.8 divided by the 8.8.
Oh,
in that equation.
Yeah, so to find the z-score, it's like the value minus the mean divided by standard deviation, right?
Yeah.
Yeah.
Okay.
So the z-score, and once it's around to 3 decimal places, would be, oh, you guys can do it too if you want, actually.
Hey, Kylie, what did you get?
1.045.
Okay. I got 2.
$1.045. That's what I just got.
Yeah.
Is that what I said?
Yeah.
Okay.
1.045454555. What I got.
Yeah, same here.
Okay.
Okay, cool.
What is, oh, sorry. Mike,
No, you're good.
else I can read
Go
numbers.
for it.
What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So don't we just put the z-score into the applet and then do anything above that?
I think so.
Okay, because that's what I was thinking.
Yeah.
I got 0.148.
Okay, so how did you do that? One more time.
So the z-score that we just calculated from question 6, I put that into the applet.
Uh-huh.
And then I made sure only the far right was highlighted blue.
Because it's more, right?
Mhm.
Because it's more than. And then just the area would be the probability. So then when you look at the area, it says 0.148.
So you put the z-score as the, okay.
Yeah.
1.045, that's what we said, right?
Yes.
And then you just do the right, and then in the area you got 0.148.
Yep.
Cool. So a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these student scores? So we just need to find the mean and then find the score after.
Like, would you find the mean of all of them by like adding them all and then dividing them,
I think
Yeah.
and then finding it from there?
I'm doing it right. Well, at least getting the mean.
It's like 160, right?
Yeah, I got 160.
160 minus, or what's the z-score? So what would be the value, though? The value.
So the value is the same one that we just had. It's the 150.8.
Oh, thanks. So then the 150.8 would become the new value, and the 160 would become the mean.
Oh, no, that's the mean. Sorry. That would be our x value, I believe.
Yeah, for finding the z-score corresponding to the sample mean, these students. So the new mean would become the 160.
So the 160 would become our x value, I believe.
Which is the value minus, so we'd go like 160 minus 150.8 divided by the 8.8.
Yep. Which is exactly what we did above, actually, in question 7.
Yeah, it's just a new mean.
Which is actually the same mean in the end.
That's the one.
Oh.
So it's still going to be the 1.045.
So what is the probability that what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Isn't it the same?
The same.
0.148?
Yeah.
I think so.
Well, we had the same mean, like the same z-score, so.
Yeah, it should be the same. If not, then we're doing something wrong. Geez, how many questions does this thing have? Oh, 15. Okay. It's like it just keeps going.
Suppose the mean GPA of BYU host students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. Drawn for what?
So
Okay.
what is the shape of the sample?
It's a large number, so wouldn't it be approximately normal because it's above that
It's above
30 or
30.
Yeah, it's above 30.
am I thinking that clearly?
No,
I think so.
say.
Okay.
What is the mean of the distribution of sample mean, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population?
Wait, what's it asking?
What's the mean of the distribution of the sample means? So the mean of the sampling distribution for all possible sample sizes.
For all possible samples of size 81 parent population. I'm like confused by the wording.
Yeah, it's really confusing.
I don't see anything in the chapter either. Maybe I'm missing it.
What's the mean? The distribution of sample mean. For all possible samples.
Unless it's just like super obvious and it's the same.
Well, the mean would 3. So we're using that information that was above, like the that the mean was 3.5 and standard deviation was 0.5.
Might it just be 3.5? Because it says a random sample is n equals 81.
That's what the, yeah.
That's the only thing I can think of because you can't, I mean, it's already taken the, I don't know what I'm trying to say, but it's like already taken the sampling distribution mean, and that's what it is, right?
I think it's 3.5.
Let's try.
Don't know what it is.
Well, that's why I was like kind of confused by it. I'm like, I don't understand what's happening because it literally gives you the answer up here.
Maybe it just wants us to pay attention, I guess. I don't know.
Yeah, that could definitely be a possibility.
What is the standard deviation of the distribution of sample means for all possible sample sizes? So this one's the, what is it? The 0.7?
Yeah, 0.7 standard deviation.
Wait.
Yeah.
Because in the chapter, just so I'm clear on this, it says the collection of all possible sample means X is also a population. The means of the distribution of the sample means is the population mean U. The standard deviation of the distribution of means is the O divided by the square root of N, where O is the parent population standard deviation and N is the sample size. So wouldn't it be the 0.7 divided by the square root of 81?
Where are you seeing that in the chapter?
It's on for review of key concepts.
Oh. I was not looking there.
It's number 2 on that.
Yeah.
Not just my thoughts. I mean, I'm willing to try it if you guys want to do the 0.7. I could try the other way and see. Because the square root of 81 is 9, right?
Yeah.
So 0.7 divided by 9, I get 0.07 repeated.
I think you're right. Yeah.
So it'd be 0.078.
For 12.
For what?
For 12.
Yeah, that's my thoughts on it. If you guys don't agree with that, that's completely fine because I
No,
may
it's
not know
like
what I'm talking about.
basically, I think it's basically word for word. I think we should trust it.
Okay.
Standard deviation of the sample means. Yeah, it's what we were talking about last time.
Yeah.
And then all possible sample means the means of distribution is U, or whatever that is.
Mean of the sample mean is mean.
So that would be 3.5.
Mm-hmm.
Yeah. So that one's right.
Oh, the standard deviation of the distribution sample means.
Okay.
Sample means is O divide or standard deviation divided by square root. Yeah. So what did you end up getting, Kylie?
0.078.
I can hurry and try too. 9.
Oh, sorry.
That's okay.
Thought it was my computer for a minute. Yeah.
Okay, cool. So, 13. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
So this one we have to find the z-score for, right?
Yeah, I think so.
Yeah, and then put it into the probability amplet.
Yeah.
So 3.3 minus 3.5 divided by 0.7 is negative 0.286.
Yes.
And then anything to the left of that, probability, does it want decimal form? Yes.
Yeah.
To the third decimal, so 0.387.
Yeah.
387. Yep.
Well, so what's the probability that it'll be greater? Can we just subtract that from 1?
That's true.
Because the probability has to equal 1. So 1 minus, what was it, 0.387?
So I think
So it's 0.613.
Yeah. Or you can click on both of them and to the right of it and do it that way without clicking the other one.
Wouldn't it be 0.387? Wouldn't it be the same?
No, because it wants anything greater than. So if you go back to the probability applet, so you do the middle bar and the right one.
Yeah, I always do that. I need to write that down.
The probability also has to equal 1. So, like this said, it's less than, and we got that number, and the next question was greater than. So if you just subtract it from 1, you get the answer as well.
That's right. Okay, so we did get the 0.613, right?
Yeah. So what? Either way.
Geez, the next one's long.
Yeah, it is. Like,
I don't even want to read it. It's so long.
that's a freaking word problem.
Yes.
I can read it.
Good for you.
Need to practice. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers was recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is an extreme or more extreme, either above or below the mean, than what was observed in this sample. And then we're going to round. So as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
So it would be the left and right?
Yeah.
Okay, so now we just need to find the z-scores.
Of these.
So we would do the 177.6 minus 185.
Mm-hmm. And then we
Divided by 26.7.
Yep.
So is the 48 commercial boating passengers, is that kind of just irrelevant information to throw us off?
I'm thinking yes.
So 0.0 or negative 0.277.
Yeah, that's what I got when I did it.
So,
and then we need to put it into the got like, and then we're gonna do the left and the right side, right? And not this
I think so.
I think that's what it's asking.
782.
Yeah, that's what I got. Hope this is right. I hate having to redo it.
You guys got 0.782?
Mm-hmm.
Yeah.
Cool.
Okay, I'm submitting mine.
Okay, I'll do the same. My laptop's about to die, so I might just get it submitted.
Okay, I got 4 wrong. And 5. And 8. And 9.
Oh gosh.
And 13 maybe, and 14 and 15.
Oh geez.
Go team.
Hey, we still got a 58%.
That's not bad.
What? Okay. Well, we can start with number 3. I can tell you guys what we got for that one.
Okay, let me find the quiz again real quick.
Yeah, me too. My laptop might die in the middle of this.
Okay.
If all of a sudden I'm gone, it's because it's dead. That's
Okay.
all. Just letting you guys know.
Okay. Oh, wait.
Then you can watch the video and the rest of the video to finish.
Okay. Sounds good. Okay.
Okay, I'm ready.
Okay. Number 3 was 0.175. Number 4, we did the first one. Maybe it's the second one.
I can't remember which ones we got wrong now.
Oh, shoot.
Yeah, we got 4 wrong.
I know we got 4, 5 wrong.
And 13, 14, and 15, and 8. I can't remember what else. Dang it, I should have left mine open.
Dang it, same. Well, I know we got 4 wrong.
I think 4 is the distribution of sample means.
4.
Mm-hmm.
Oh, yeah, that makes more sense. I think.
Well, we shall see.
That makes a little more sense because the distribution of sample mean, so it's the mean. So it's a distribution based on the mean versus if you do it on individual observation, say your individual observation went from 180 to like 290, then you have a deviation of 110 there, but the mean would be based off of, if you did it based off of the mean, then it would be smaller, I think.
Yeah.
Okay. So distribution of sample means.
And 5 we got incorrect.
Is it normal distribution, do you think?
I don't know. I thought it might be the.
We did the central limit theorem last time.
Yeah. And I don't think it's the 68, 95, 97. Right.
It's either the normal distribution or the law of large numbers.
Maybe let's try normal distribution.
Yeah, it's the law of large numbers.
You guys can try something else too if you like. I don't know. That's what my gut's leaning towards. That's usually what I do if I don't know.
I think it might be the law of large numbers, actually. Because which of the following results implies that the spread of data, so like it decreases, it becomes closer, right? If it's decreasing. And as the sample size increases, because the law of large numbers says as the sample size is larger, so it's increasing, the sample mean, so like the spread of the data, the sample mean will get closer to the population mean.
Oh.
I think you're right.
Yeah.
That's what I'm thinking. I don't even know what the normal distribution is. What's a normal distribution?
Normal is just the bell-shaped curve.
Oh, okay. Right.
Okay. 6. I think we got 6 right.
And
I
that
think
was
so too.
1.045.
And 7
7.
is 0.
0.148.
And then 8 was wrong.
Oh, shoot.
I think.
Yeah, I think 8 was wrong.
So last time we added all of them up, divided it, got our mean, and then just found the z-score from there. And I still feel like that's it. Eight hundred. 1, 2, 3, 4, 5, 5, 5, 5.
I like all of a sudden do not feel ready to take this test next week.
No.
Oh, wait. Okay, this part from the chapter says, if a sample mean is normally distributed, which it is, and we can consider the sample mean x, it would be finding the mean of these numbers, as one observation from a normal distribution with the mean u, and the standard deviation is the O divided by the square root of n. So our n here would be 5. Square root of 5 is, does it have a square root? I don't think so. That would make it complicated. But the calculator would give something to us.
Is there a square root of 160? I don't know why. That was the actual mean that we got.
Okay, well, shut it. You're not in the class, Joey.
Square root of 5 is 2.23.
Yeah, 2.2361.
Yeah.
We could round that far back if we wanted and try that.
Yeah, let's try it.
So our mean was still 160.
Mm-hmm.
So we would do 160 minus the 150.8.
Yes.
Oh, wait. Never mind. Well, we will do that. But then this, so let's figure out the standard deviation. So it would be 8.8 divided by that 2.23. 1 or 6.1. So 8.8 divided by 2.2361. Your phone. Okay, I got an overall answer.
I think it's 2.338.
Okay, that's what I got.
I got 2, and I can try it out.
Worth a shot. That's what the chapter made it sound like. So, and that was under big point 3.
Okay.
Big point 3. What were you talking about there? Oh, like how to do it? That. Oh, I see.
Yeah.
Right. I'm like, what?
Sorry.
Okay. Did we get number 9 wrong or wrong?
I don't remember anymore.
I don't remember. Let's just put what you have.
Because I have a 0.148.
I think we got 10 right. That was normal.
Yeah, I think we did get 10 right.
And I think we got 11 right. Because I think it was just 13 through 15 that we got wrong next, right?
Oh, yeah, because I thought it was funny that 11 was right, but the other ones weren't.
Yeah.
Because 11 was 3.5, right?
I think so. And then what was 12?
12 was 0.078.
I think we got that one right. So it was 13 through 15 that we got wrong. And my laptop's at 2% and it's telling me it's going to go to sleep. So I'm going to hop off and then I'll just watch the video for the last 3 questions later tonight when I can get a charger, okay?
See, that sounds
Okay.
good.
Okay, bye.
Bye.
Wait, what was the answer for 12, Melissa?
0.078.
Okay, which one do you want to work on now? Do you want to go through 13 or do you want to go back to that one
Why
that we
am
left
I
empty?
thinking that number 9 is wrong?
9.
Yeah, I'm still stuck on thinking that we got that wrong.
So what is the probability that the 5 randomly selected students will have a mean score that is greater than the mean achieved?
Because wouldn't it change since we're changing our answer in 8?
Yeah, I think 9's wrong. I think we got 8 and 9 wrong.
And I think the 13, 14, 15.
Mm-hmm.
Because it would, okay, so it's a probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem. So wouldn't we take the z-score and we need to put it in the probability amplet and then do the greater then, right?
I think so. So this z-score is what?
2.338.
2.338.
Uh-huh. Ooh, I wanted 2.338.
And what was the mean of the other one? Because it asks.
What other one? On the top, that mean was 150.8.
For the z-score?
Oh, for that z. Oh, okay. I'm confusing your
Sorry.
score from what we got in number 6.
Okay, sorry, I'm just trying to think. What is the probability that the 5 randomly selected students will have a mean score greater than the mean achieved by the students in the previous problem?
So would we find the difference between that? So
That's what I'm wondering.
well, this one was, sounds like 0.9903 minus, what was this one?
Or maybe it's not, because it said to round to the 4 decimal places,
148.
which is 0.0097. If you just did the,
Yeah,
I mean, we could always submit yours and then wait and see, and then both submit our second chance together.
yeah. I think
Because
so.
this is your first chance still, right?
Mhm. Yeah. So the 0, because that's what I was got, like the 0.0097, right?
Yeah, let's try that.
Okay, so now we're on 13, right? You got all those other ones filled in between.
Mm-hmm.
Okay. 13. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
Oh, I think I know why we got this one wrong.
Well, that's good.
Because you know how we just figured out that longer one with the square root for the standard deviation in part 3?
Mm-hmm.
So we need to do that for this problem as well. So the 3.3 minus 3.5 divided by the answer from question 12, I think.
Okay, I'm not sure. So like the longer one, like how we did. Wait, what? This probably GPA for is it 81? Maybe less than 3.2. I'm not sure I'm understanding what you were saying. Actually, I thought I was doing it, but
No, you're fine. So this one gives us the N of 81, right? Because it says 81 randomly selected students.
yes.
Whereas above it asked us to calculate that, and so we did the 81, the square root of 81 with the regular standard deviation, which was 0.7 or 0.07, whatever it was. From up here, 0.7. So we did the 0.7 divided by 9 to get a 3.5 for 11, right?
Mm-hmm.
And then, so in the chapter, if we go to that big 0.3, like we were talking about earlier,
Yeah.
we do the value of x, which would be our 3.3 for question 13, minus the 3.5, which is the mean, divided by the standard deviation, which we found in the previous problem.
Previous problem. Okay.
Is that making more sense?
Yeah. Yeah, it is helping.
Did you get an answer for that, Melissa?
Not yet. I'm still trying. So I would go the value, which was the 81, right?
No, the 3.3.
I'll see that. 2.3 minus. Mean from 0, 0.07 modified.
And then the answer you get should be your z-score, so you would plug that into the probability applet.
Okay.
What did you get for your answer?
Yeah, plug it. like 0.005.
That's what I got.
Okay.
And then 14 is greater than, so that I just unclicked the tiny box and clicked the next two.
Mm-hmm.
I don't know if this is right, but this is my thought process.
995.
Mm-hmm. That's what I got as well.
Okay, healthy. Okay, 15.
Because I got this one wrong too.
Yeah.
Oh, I know why. Because we have the random sample of 48. And since it's asking us specifically about the probability of the random sample, we need to do the square root of 48 and find the standard of deviation that way, I think.
6 instead of 48.
Sorry, what? Joey's running the sync, so.
Oh, 6 times
What did you say?
36. Wait, what's the square root of 48?
Joey, did you take it? Oh, never mind. I found it. Okay. Does it have it?
Oh, 6.92.
48. Yeah. Square root.
So the square
6.9.
root of 48 is 6.9. Oh my goodness, 6.9282.
Okay, so then the standard deviation, we would do the 26.7 divided by that number, 6.9282.
0.922.
Yeah. So I got 3.853814.
6.928. Yeah.
Okay. Sorry, I'm using two calculators so I don't lose my my number.
Well,
Okay, so then I stole Joey's phone.
I'm really missing my graphing calculator right now.
Right. I wish I would have had that. Okay, so then we would take the 177.6, which is our sample mean, minus the 185, which is the general mean, which gives us negative 7.4, right?
Yes.
And divide that by the 3.8.
See, now I lost it.
3, 8. I'll just go that far. And got negative. So then we put this number as our z-score. I think. I hope this is right. Negative 1.9202. Then it rounds for us. And once greater than and less than. Which would you get for that?
Greater than that. 0.055.
Is that rounding? 5.5? Yeah. 0.055.
Yeah.
Okay. Dare you try it?
Okay.
Hope we got 100.
Guess what?
What?
We did it.
We got 100?
Yeah.
Okay, I'm gonna go back through the answers for Mikkel, so she has a clear, then she doesn't have to figure it out through our speaking. Unless she does that anyways, that's fine.
What if I show my screen?
That's true, you could probably do that.
How do I do that?
I don't know.
Oh, you guys figured it out last time.
Oh, I could do it if you want. Oh, you click, so you hover your mouse in the screen. Oh, there you go. See, there's me. Oh, wow, I look atrocious.
Okay, wait. Where am I? Can you see this?
Yeah, I can.
1 true. 2 true. Okay. 3, 0.175. Just tell me when you're ready for me to move on.
Yeah.
4, the distribution of sample means.
Yep.
5, law of large numbers.
Yep.
6, 1.045.
Yep.
7, 0.148.
Yep.
8, 2.338.
Yep.
9, 0.0097.
Yep.
10, normal.
Yep.
11, 3.5.
Yep.
12, 0.078.
Yep.
13, 0.005.
Yep.
14, 0.995.
Yep.
15, 0.055.
Yeah, I'm glad we figured out how to do those right.
Yeah, me too. It was stressful for a minute. Okay, well,
Now I feel a little more prepared for the quiz now that I realize that sample size thingy.
yeah, that was good. That was all in number 3, right?
Yeah, it was just really what screwed us over was we didn't find the new standard deviation, which threw us off for the answers on the rest of the problems.
Yeah. Yes, it did.
Oh, that's nice.
Okay, well, that was fun. That was good. Now I need to make dinner.
Yeah, I ate dinner while we were talking because I was hungry, and now I gotta help clean and stuff.
Sorry.
Yeah, that's
Well,
okay.
best of luck.
Have fun. Let me know if you needed help on the homework or anything again.
Yeah, from trouble. I haven't done 6 yet, or
I haven't done either of them yet,
so
and I'm supposed to be moving the next 2 days, so yeah, it'll probably be last minute again, but it's fine.
I'm probably gonna do 6 right now once I get dinner. So
Yeah, that's nice.
I'll let you know.
Okay.
Okay, talk to you later.
Talk to you later. Bye.